The NETAPP community is an endeavor that 5GASP has created to join and gather developers from projects, but also SMEs and individual developers that are working in the area of 5G. We've created a website that includes lots of resources, but I will leave that for Roman to explain to you at the end of our webinar. We will have a 2-hour duration. We will make a short break after the 2 initial presentations and before the panel discussion, and hope everyone enjoys and learns from today's sessions. So without any further delay, I invite Rudolf from ININ to start his presentation.
Hello, and thank you for the introduction. Just a couple of seconds to can you give me the rights to share my screen? Okay. Okay, so I can assume, may I assume you can see my screen? Okay. So as mentioned, today NETAPP case study will discuss on 5G isolated operations for public safety. So this is a NETAPP that has been developed by the Internet Institute, a startup company from Slovenia. So it's about how we can customize communication services for the PPDR, so public protection and disaster relief communication vertical, by meeting the requirements of that vertical. We will present the basic idea, design and implementation of our NETAPP. So public protection and disaster relief services are mission critical services that are usually operated by firefighters, paramedics, and people like that. So we can agree that such kind of users need to communicate among themselves. Well, mainly this would be voice. So if we can imagine a firefighter in a hot zone where the temperature goes above 300 or even 400 degrees Celsius, then we can somehow imagine that the main communication choice would be voice. So this might be one of the reasons why many of the today PPDR communication systems rely on narrowband technologies. Some of them are analog systems and, well, let's say majority digital systems, but even so, systems like Tetra cannot be actually considered as a broadband comparing to technologies which we see today in the commercial systems. Anyhow, ITU considers that 5G as well as LTE advanced is able to address needs of mission critical requirements. As well, EU-funded projects BroadMap and Broadway are somehow trying to close the technological gap between today legacy PPDR systems and commercial systems like 5G and LTE. Looking around the world, we see that some nation-level broadband deployments based on 4G or 5G are already in operation, as well some are expected to be launched soon. If we want to deal with the PPDR vertical, so if we want to do some technological innovations in this field, we of course, first of all, need to know what are the requirements of the PPDR. So this would be, as one may imagine, high availability, high resilience, scalability. There is also one important thing, interoperability across administration borders, which is, by the way, not supported by today legacy PPDR systems. We also would say that such systems need guaranteed quality of service, let's say in some sort of prioritization, as well as energy efficiency. And it's also important that the technology supports novel use cases, which might be at the moment most likely operated by technologies which are not considered as mission critical. So let's get back to the isolated operations. The isolated operations is all about assuring uninterruptible services for the PPDR users in our particular case. So the picture here depicts what we call a day-to-day operation scenarios. We have a cell site, so a base station to which 5G or whatever device is connected. So the cell site provides network access, while the applications or services are supported by the core network, which resides in the core site, which is physically remote comparing to the cell sites. So in between we have a backhaul, which, let's say in the case of a disaster, fails. So now at this moment, the user device is no more able to reach the core network in the core site. So the only way to preserve the services running is to activate kind of local 5G core network, which will provide us with some basic connectivity and basic services. So the 5G architecture, as proposed today, is able to support this, since on the physical level, the cell site should be equipped with server infrastructure, of course not as powerful as the infrastructure on the centralized site, but anyway, in our case, it should have enough power to provide running to NETAPP components. So our isolated operation is divided into NETAPP components. One is called cloud baseband unit, which provides network connectivity, so together in cooperation with radio heads and all the antenna stuff. And the other NETAPP, which also should reside on the cell site, is so-called local 5G core network, which would be activated in case backhaul between cell site and core site fails. So core site, or so-called macro 5G core network, can be in general a core network of any public mobile provider. So we can also consider, as we will see further, the hardware infrastructure necessary to provide support for those NETAPPs may not be such huge in physical format, so we can prepare this hardware as in the form of the kind of a bigger suitcase. So we can also explain this use case as a portable cell site, which the PPDR unit can carry with them to locations where they need to operate. So this cell can connect actually to any core, so any public core. So today it might be an mobile operator in Slovenia, tomorrow in Portugal, in UK or Greece or wherever. So in case of day-to-day operation, nothing special is there. So the user device connects through the cell site and baseband unit NETAPP via the backhaul to the macro 5G network, core network, which provides then PPDR services and internet access. Then in case of disaster, baseband unit NETAPP will detect the macro 5G core network is no more responsible, so the local 5G core network needs to be activated, and thus providing some local PPDR services. So of course, these are only limited set of services providing only mission critical basic services and connectivity. We also need to say something what happens on the side of the user device. So in this case, when we have a day-to-day operation, the radio broadcasts cell ID of the macro network. Then when the macro network fails and local 5G core network is activated, the cell would advertise this local 5G core network ID, which means that a device connected to the network needs to change its identity in order if it would want to preserve the services running. So usually this would mean that user device has a dual SIM, one SIM carrying identity to attach for the core network to the macro network, and the other use SIM with the identity to attach to the local 5G core network. So in case the 5G PPDR users are sharing the network with the public users, this would mean that in case when we have a local 5G core network activated, only those devices which also have appropriate SIM identity will be able to connect to the isolated operations network. So isolated means the mode when local 5G core network is in action. So when there is no connectivity to the core site. Then hopefully at a certain point in time, macro 5G core network will be back. Baseband unit NETAPP will detect this, and local 5G core network component will be deactivated. And now again, the cell will broadcast identity of the macro 5G core network. Devices will again need to switch to appropriate identity, as well public users, in case this is the case, will be able to attach to the network again, and all usual services, including internet access, will be available for all kinds of the users. So next, here we have a list of requirements we think our NETAPP solution should support. So we envision the reconfiguration time would be less than 300 seconds. And in terms of mission critical support network KPIs, we we need to support user prioritization. We also have set some KPIs regarding the bandwidth, which should be, let's say, 300 megabits per second, round trip time less than 10 milliseconds, maximum packet loss rate maximum, so 10 to the power of -6, and so on. So at the moment, the development has not been finished yet, so we will see how good the NETAPP or the complete solution will meet these requirements when we will start testing, and probably some tuning will be necessary then. So in terms of requirements regarding the deployment, so many hardware requirements, this would mean so regarding deployment requirements, both NetApps will be delivered as a containers, packaged as a VNF or CNF. Both NetApps will require, well, we expect it will require 4 CPU cores, 16 gigabytes of RAM and 20 gigabytes of storage. Well, we will see that maybe even less will be enough. So during the test, we will see what is really necessary here. Then regarding the hardware, nothing special there is needed, except there is one, let's say, specific for the baseband unit, which of course needs to be connected to the radio head, which goes via common public radio interface. So we also need to provide sort of card, PCI card, for example, to link the server where the baseband unit NetApps run and the radio head. The other thing here that needs to be highlighted is the core network app must include, so it includes all essential 5G core network elements like home subscriber server, user plane function, access and mobility function, and so on. So to conclude, we believe that our study will help to encourage PPDR communication system transition to 5G and other novel technologies. So the main goal of our solution is to maintain the level of communication for PPDR users even during the disaster situations occurs. The approach of the solution is based on 2 NetApps. No special hardware requirements for the implementations, so except the connection to the radio head. In general, we can say that the solution operates as a standardized mobile system with roaming options. So as we said, this allows us to have a cross-border operations. And after all, we know that PPDR vertical has not huge market potential compared to automotive, transport, and industrial verticals. But the PPDR is of crucial importance for the safety of the European society and the society at all. So we at Internet Institute are therefore not only engineers, but also some of us are volunteer firefighters. Thank you.
Thank you so much, Rudolf, for a very interesting presentation. Since we finished the presentation a little bit earlier, instead of leaving the questions for our break, I would leave the speaker open for questions. Of course, you cannot speak unless I can give you permission to. So have your questions in through the Q&A or through the chat. You can write into the chat, and I will proxy the questions to Rudolf. While we wait for questions, I would ask you one question, Rudolf. In this process of developing a NETAPP, what were the most important challenges in terms of software support? Did you find the tools necessary to develop your app, your NETAPP?
Well, yeah, there are of course many challenges. So starting with the environment which we need to set up on that would be more in terms of the development. So the setting up the environment on the servers. There are of course some specifics, like we have to do some changes in providing the orchestration, like one of them would be support for the common public radio interface connection. But after all, our solution is based on the commercial software. So the main part of this development goes how to build these blocks together. One of them, of course, how to detect when we have a disaster situation, so that we need to switch to the isolated operation. And of course, we need to do as fast as possible, so not to interrupt the user sessions too much. And as well, there is a challenge, let's say, which is not fully covered. I mean, it's not in the scope of the development of the NETAPP. So this depends on what we need to be supported on the device side. So changing the SIM identity when when switching from the day-to-day operations to the isolated operations. So I hope this answers your question.
Thank you. We have a question by Jorge Pereira. I will read this question. I understand that apps aspects of PPDR, but I do not really see how you ensure compliance with the PPDR KPIs, as they are not available yet.
Yeah, well, let's say in free GPP specifications, we have some guidelines how to approach this problem. So we try to stick with this. Otherwise, yeah, we'll let's say we have some insight into the PPDR through the collaboration with our colleagues from the civil protections and firefighters units. So we also work closely with them. And well, when these requirements will be like more standardized, we will need to do somehow another round of tuning, and we also try to have the solution open, so that all new requirements will hopefully be incorporated without big effort, or with let's say not much effort.
Okay, Gregor Bow asks, wouldn't there be a challenge to secure various user equipment devices for PPDR, which would support dual SIM configuration?
Yeah, of course. This would be well, let's say it's more on the side of the PPDR users, but of course I totally agree here, and I think this would be a kind of approach that PPDR users has a kind of custom made or special devices, as is already case today with legacy systems. So these devices will probably need to be somehow special. And hope I have answered the question.
Okay. Bessem Sayed asks, what is the difference between what you call a NETAPP and a slice?
Well, actually, yes, our solution is kind of slice. So
maybe I can also help here, knowing us a little bit about the project. There are aspects that are part of the network slice, but there's also software that is deployed as an application side. And this is, NetApps require slices, but they're not 100% a slice.